So these were the couple of questions that came up that were emailed to me. Like I said, if you have other homework questions at any time, email me or in the chat, type them, and we'll find time to get to them. So here on 89A, it was log base x of 25 equals 1. So in general, I just kind of want to remind us, we never took notes on this formally, and we will hopefully next week. So if we have like n equals x, I shouldn't have used x, just want to use random letters. B to the m, these are going to be equivalent. So this is exponential form. The equivalent log form would be m equals log base b of n. So here, if we have it in log form, if x is the base down here, that's what I was calling b, that would be what's by itself. The number by itself, m, becomes the exponent, and what you're taking log of becomes by itself. So it kind of just switches everything around. So if we rewrite this in exponential form, it becomes 25 equals x to the first power. So that just tells us that x is 25. And then here, same idea, this is log form, so if I rewrite it in exponential form, 3 to the 1/2 power equals x. The 1/2 power is the same as the square root, so that's just the square root of 3. I don't remember the directions. You can leave it like that. You can make it a decimal, whatever works better, or your preference. Problem 92, it was kind of weird. You had a paragraph to read. It was kind of long. And it basically says that there's these aliens, and when they do logs, they don't use a base of 10. They use some other base, and your goal is to figure out what the base is. So if you don't know what I'm talking about, you probably didn't read this problem. I was trying to pull it up, but it's kind of taking a while. But so again, it was some alien problem, these weird creatures. And so these were the 3 things that they gave us. Log base 10 is 0.09266, so on. They gave us log of 100 and log of 1,000. So our goal is to figure out what the base is. And all of these would have the same base, they just don't write it. Just like we do base 10 and don't write it. So this is some base b for all of these. And our goal is to figure out the base. So if I rewrite this top one in exponential form, that would be b to the power of 0.0926628,408 is equal to 10. I wrote the b in the wrong spot there. I apologize. It should be there. This one would be b to the power of 1.853256816 equals 100. And so what you're doing on this problem, and we could write it for this one. It doesn't tell us you have to. Your goal basically is just to figure out what the base is. And really the only way, we could take the root on each side, or we can guess and check. Those are your 2 options. Let me get my graphing calculator. So if we wanted to, on this top one, take the root, and it's going to be the root of that really long decimal. So I would do, I'd have to type that long decimal in 0.09266. Oh, I wrote it wrong. 0.9, I apologize. 266, 28408 of 10. And we get 12. So basically you take this root, 0.9266, ... And that tells us that B equals 12. I'm all over the place today, I apologize. So we could check it on this next one. 12 to the power of 1.853256816. And this is pretty much 100. They must have rounded a little bit. Obviously, we know calculators round, especially when they get long like that. So the base is 12 here. Then the problem says, well, how many fingers do you think these aliens that came on this spaceship have? And they probably have 12 fingers. We use base 10, we have 10 fingers. So that's kind of what they were getting at there. All right. So we're gonna do some examples for your chapter 5 review homework tonight. Sorry, we have 10 problems that we're going to do here. So number 1 is 2y to the negative third times 2x cubed in parentheses all to the third power. And the directions say to simplify and only have positive exponents. So the first thing I would do here is I would distribute this 3 on the outside of my parentheses. And you could also get rid of this negative exponent at the same time. So this is 2 over y cubed. The negative 3 is only with the y, so it takes it to the denominator, and the exponent becomes positive, times 2 to the third x to the ninth. Remember, you're distributing this exponent and multiplying. And right here on this 2, we have an exponent of 1 that we don't write. Well, and we also know that this is over 1. So we just multiply straight across. 2 times 2 to the third is 2 to the fourth x to the ninth over y cubed. 1, 2, and 3 more there. We have 4 of them. Or we can just multiply it out. So 2 to the fourth is 2. So 4 2s. 2, 4, 8, 16. So we get 16x to the ninth over y cubed. Number 2 is x squared y to the negative 1 divided by xy to the fourth. And here you have a couple of different options on how you want to approach it. You could write it out the long way. You could flip your negative exponents first and then write it out the long way. Maybe you remember all your rules for exponents. The first thing I'm going to do is I'm just going to get rid of my negative exponent. I'm not going to simplify anything else. Some of you will combine these steps, and that's fine. So that's just x squared over x y to the fourth times y to the power of 1. Again, y to the negative 1 in the numerator moves it to the denominator, and the exponent becomes positive. So again, if you want to write it out, you can. But in my numerator, I have 2 x's and I only have 1 x in my denominator. So I have 1 more on the top. And basically you can subtract those exponents. So we end up with x in my numerator. Here I have 4 y's and here I have 1 more. All in the denominator, so they stay in the denominator. X over y to the 5th.
What about that 1x on the bottom?
So if I think about, if I write this the long way, it's x times x over x times. So that's writing it out the long way. And then you can see that one of the x's on top and one on bottom cross out. And if you don't remember the shortcuts, write it out. That took me, what, maybe 10 seconds? And if that's going to help me get the problem right, then it's worth the 10 seconds. Because you might take just as long trying to kind of figure it out otherwise. All right, number 3 is solving 125 to the power of negative 3b minus 3 equals 625. So when you're doing these problems, you need to, whenever we're solving for an exponent, we need to get the same base. So I need to rewrite this left side as something to some power, and then the negative 3b minus 3 is still that exponent. And then on this right side, I also need that same base to some power. So you kind of ask yourself, and maybe it's pure guessing and checking, what number can I multiply by itself? I don't know how many times, but several times to get 125. So you should know that 5 goes into it, so that's a good place to start. And again, if you're not sure, just check. So on your calculator, you can just kind of type them in. 5 to the power of 2, we know is 25. 5 to the power of 3 is 125. So this 125 can be rewritten as 5 cubed. And then 625, we just keep going, and we see that it's 5 to the 4th. So I can rewrite 625 as 5 to the 4th power. Now that my 5s are the same, they essentially just go away. The same base, so that means their exponents are the same. So that tells us on this right side, I have, left side, I'm sorry, negative 9b minus 9 is equal to 4. Again, this becomes this because we are distributing on that side. Oops, sorry. And then from there, we just solve it, add 9 on both sides. Negative 9b equals 13, divide by negative 9. We get b equals negative 13 over 9. Typically, we just bring the negative out in front. We know a positive divided by a negative is a negative. All right. Number 4, same idea. 6 to the power of 2 minus 3n is equal to 1 over 216. So 6 cannot be rewritten as anything times itself. We know 6 is 1 times 6 or 2 times 3, but it's not the same number times itself. So our goal here is going to be to rewrite the 216 with a base of 6. So our goal over here is to have a base of 6. So off to the side, I'm just going to kind of, so 6 squared we know is 36. 6 cubed, so 6 to the power of 3 is 216. But this is 1 over 216. So that tells us that we need 6 to the negative third, and that'll give us the 1 over 216. Remember, negative exponents, move it to the denominator. If you check on your calculator, it's going to give you a decimal. Remember, you can turn that into a fraction by pushing that math button. And we confirm that 6 to the power of -3 is 1/216. So if it's a fraction, figure out just how to get that denominator, and then you make your exponent negative. So that's to the power of -3. So 2 minus 3n equals -3. Subtract 2 on both sides, -3n equals -5. Divide by -3, and n is 5/3. Negative divided by a negative is a positive. So number 5 is gives you two functions. G of n is -4 minus 4/5 n, and f of n is -5/4 n minus 5. So we want to know, are they inverses? It's just a yes or no question. And you have several options actually. You can make a table for each one and see that they're flipped. You can graph each one and see if it's a reflection across the line y equals x. You can plug in points. The problem with plugging in points, it has to be true for more than just one point. So if you plug in 1 point and it doesn't work, well, then they're not inverses. But if you plug in 1 point and it does work, you still need to check another one. Because they're linear, if you check 2 points and it works, then that would be fine. Or you can do it by writing out the steps and just seeing if the equations match. So I'll kind of show you two different ways here just so you know. So say we do g of 0. So I have -4 minus 4/5 times 0. Well, that's -4 minus 0, which is just -4. So that means I want to plug -4 in for f of n. So f of -4 equals -5/4 times -4 minus 5. We know when we multiply a fraction by a whole number, that's like putting it over 1, the whole number with a 1 under it. So these 4's cross out, essentially numerator and denominator. And negative times the negative, we get +5 minus 5, we get 0. So it worked. So it lets us think that these are probably inverses, but again, you should check another point because we know this is linear. Or like I said, we can write out the steps. So when it's a fraction, what I would recommend doing, you can multiply by 4/5. Personally, I think it's easier to break that into 2 steps. So for g of n, the first step is to multiply by -4. The second step would be to divide by 5. And it's not -5. You only do one of those as negative. Again, if I told you n was 7 and you didn't have your calculator, you would do 4 times 7, and then you would divide that by 5, or -4 times 7. And then your third step would be to subtract that 4 that's out in front. We know that -4 could also be at the end. So for our inverse, remember you flip the steps and the order. So we would add 4, then we would multiply by 5, then we would divide by -4. So that gives us the equation n plus 4, multiply that whole thing by 5, divide that whole thing by -4. And we need to know if this inverse is equivalent to this equation here, f of n. So if we distribute and simplify, this becomes 5n plus 20 all divided by -4. So if I divide each term by -4, I get -5/4 n minus 5. Positive 20 divided by -4 becomes -5. So it does work. So yes, they are inverses. And they might not look like it when you first look because this one has a 4 and this one has a 5. They're negatives all around. So just because they don't look like inverses doesn't mean they're not. Questions so far? Again, we also could have graphed these. You can graph them on Desmos or your graphing calculator. Number 6 says rewrite in exponential form. So it's log base 11 of 121 equals 2. So the exponential form, the base of the log is the base. The number by itself becomes the exponent, equals 121. And we know that's true. 11 squared is 121. And that's how logs work. Remember, you're asking yourself 11 to some power gives me 121. Rewrite in log form. And the problem is 8 squared equals 64. So that's a true statement. So if I want to rewrite this in log form, give you guys a second to write that down in case you're behind. So this would be log, the base of the log is the base of the exponent. Log base 8 of the number by itself is equal to 2. So log base 8 of 64 is equal to 2. So number 8 just says evaluate log base 3 of 1/27. So you should be doing this without a calculator. Basically, they're just saying, hey, what is this equal to? I shouldn't have used a B. B I usually use for base. I apologize. Let's just call it X. So what is this equal to? Basically, 3 to what power gives us 1/27? That's what they're asking in this problem.
Isn't it negative?
What?
Isn't it gonna be negative?
I cannot hear you. I'm sorry. Do you want to put it in the chat? So because it's 1 over something, we know it will be a negative number. So that's kind of what you're asking yourself here. 3 to what power gives me 1/27? Well, we know 3 to the third is 27. So 3 to the negative third would be 1/27. So that just tells us X in this problem is -3, or this is equal to -3. All right. 2 more. Find the domain and range and sketch the graph. And the equation here is y equals log of x minus 1 minus 3. Okay, so just to remind you, and I'll kind of write it off to the side, if we just graphed y equals log of x, we know it looks like that, where it goes through the point 1, 0. So we should know that a regular log graph goes through the point 1, 0, because a regular exponential graph without any shifts goes through 0, 1, and they're inverses. So how does that help us here? Well, we know that this makes it go right 1, and this makes it go down 3. On this graph, we also know we have our asymptote here at the axis. Hard to see that highlighter. So this point is going to go right 1 and down 3. So it was here at 1, 0, right 1 and down 3 is now the point 2, negative 3. And our asymptote that was here at the y-axis moves right 1. So now we have an asymptote right here. And the graph just looks the same. That's kind of that locator point we would use. And it's going to curve like that, with this being the asymptote. So our domain is x is greater than 1. Notice that's my h value. That's always the case. X is greater than your h value, because that's where we have our asymptote. Our asymptote is always there. And then our range here is just all real numbers. For these log graphs, they go down forever and they go up forever. They just go up more slowly. And finally, number 10, find the inverse, graph both. So it wants us to graph both the function and the inverse, just kind of abbreviating those directions. F of x equals negative 2x cubed plus 2. So to find the inverse, what I would do first is I would personally list out the steps. Remember, your other option to finding the inverse is you can switch x and y and solve. If you're good at algebra, then you can do that option. And if you're thinking maybe not, then just list the steps. So again, if I told you x was the number 5 or 7 or any number, what would you do without your calculator? What are your order of operations? So the first thing you would do is cube it. The next thing you would do is multiply by negative 2. And then you would add 2. So for my inverse, remember we do the opposite steps. We undo each one in the reverse order. So instead of adding 2, we subtract 2. instead of multiplying by 2, we divide by -2. And then instead of cubing it, we cube root it. So the inverse here, remember we use the -1 after the f, would be x minus 2 divided by -2, and then the cube root of that whole thing. I want to point out that this can be simplified. A lot of the times we don't leave a negative in our denominator. So if this is a multiple choice problem, this would be equivalent to the cube root of -x plus 2 over 2. So basically you're dividing everything by a negative, and that's where the -x and the plus 2 comes from. It's also equivalent to -x over 2 plus 1. So if it was a multiple, and that's just dividing each part by the 2 and separating it. So if it's a multiple choice problem, you would just have to keep going until you found what one it simplified to. So if we're graphing this original function, -2x cubed plus 2, just kind of taking it back to remind you, that would tell us that a is -2, h is 0, and k is 2. Back from chapter 2, our parent graphs. So we'd have this point here at 0, 2. That's my hk, and a being -2 makes it go like this. And then to graph the inverse, you have a couple of options. You could try to graph this with the a, h, and k. This one's not as easy. You could put it on Desmos. Or remember, you can use the fact that it reflects over this line, x equals y, and sketch your graph that way. So that point 0, 2 becomes 2, 0. And this one let's see, goes like that. Remember, if you fold it on that line, you would see that they would match up. All right, that was the last one we had today. Before you go, a couple of things. So this assignment in CUDA, the CUDA Works assignment that you have to log into, is due tomorrow by 3 p.m. Though you need to show your work, but you'll turn that work in on Monday. The reason this assignment is due tomorrow by 3 p.m. is because that is how your attendance is taken tomorrow. So if this is not completed by tomorrow at 3, and I don't hear from you otherwise, then you are marked absent. So just wanted to clarify that for some of you. So make sure you get that done. And then reminder, you do have a test next week on Tuesday. So if you have questions while you're doing your homework either tonight or over the weekend, make sure you bring them on Monday. But other than that, we're good. So you guys are free to go unless you stick around for questions, and I will see you Monday. Have a good weekend. Make sure this gets done.